Hi students, today we discuss about the diameter of Newton's ring. We actually measure the diameter of Newton's rings. At first, we know that this is the plano-convex lens and this is the plane glass plate. Now, if we take these are Newton's rings and we take these rings and which have the radius r. Now this Newton's ring is formed if at this height, at height t from plane glass plate. Now AB is the diameter of these rings, these rings. So the diameter of these rings is AB, which is formed at height t from the plane glass plate. Now this plano-convex lens is part of this circle and which have the center at M and the radius is capital R, which is capital R, and the radius of this Newton's ring is smaller. So OB equals to AO equals to smaller and PM equals to MQ equals to capital R, and OQ equals to T, which is the thickness of the thin wedge film. Now from property of circle we have actually PO cross OQ equals to AO cross OB. We have from the property of circle actually the multiplication of PO and OQ equals to AO and OB. Now PQ actually, which is 2R minus T, this is R, and MQ equals to R. So PO equals to 2R minus T, actually this R and this R, so 2R minus T. So PO equals to 2R minus T and OQ equals to T and AO equals to R and R, which is the radius of the Newton's ring. Now 2R minus T and into T equals to 2RT minus T square equals to R square. Now T square, as T is very less than 2R, actually T is very less than R, so T square is negligible. Now so T equals to R square. Now T equals to R square by 2R. So we have, this is the thickness of the wedge shaped film and where the Newton's ring is formed from the plane glass plate. Now diameter for bright rings, we have the condition for bright rings path difference equals to even multiple of lambda by 2. So path difference, which we have in the previous class, actually we get from this class, or we have this path difference actually 2 mu t cos theta plus r plus lambda by 2, the lambda by 2 which we have from Stokes treatment. Now even multiple 2n into lambda by 2, where n is the order, n equals to 1 2 3 dot 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 order. Now 2 mu t cos theta plus r, for normal incident this is equals to 1, theta and r equals to 0, so cos 0 and cos 0 equals to 1. So we have 2 mu t equals to 2n minus 1 lambda by 2. Now we put the t, the value of t which we have from this expression, t equals to r square by 2r. Now 2 mu t, 2 mu into t r square by 2r equals to 2n minus 1 lambda by 2. So 2 mu 2 cancel out, and now r square equals to r by 2 mu 2n minus 1 lambda. Now r is the radius of the Newton's ring, and so dn, if we take the diameter of nth rings, the diameter of nth bright ring. Now dn equals to 2 rn. This is if this is rn. Now dn by 2 whole square and r lambda by 2 mu 2n minus 1. Now dn square equals to 2 r lambda by mu 2n minus 1. So dn equals to root over of 2 r lambda by mu and 2n minus 1. Now r is constant, lambda is constant, which is monochromatic source, and mu is constant also. Mu is the refractive index of this Weiss field, and r is the radius of curvature of this plano-convex lens, and lambda is the wavelength of the light which we use. And now dn proportional to root over of 2n minus 1. Actually this is very important for your exam. Actually questions which we get in the exam, actually the diameter of bright rings, is proportional to odd number of, actually square root of odd number. What the question? Prove that the diameter of bright of bright rings, diameter of bright rings is proportional to the square root of odd numbers. So this is the question actually which you get in your exam. Prove that the diameter of bright rings is proportional to the square root of odd numbers. 2n, actually this is even number and -1, so this is the odd number. So dn is proportional to the square root of odd numbers, which is very important for your exam. And why this is proportional? Because r, lambda and mu is constant. Now diameter for dark rings and same path difference actually we get from the previous class. If you can't understand, then you can see in the previous class, the previous video which I discussed in this video, actually how we get the path difference. Path difference equals to odd multiple of lambda by 2. Now path difference, which we have 2 mu t cos theta plus r, which theta equals to actually the angle between plane convex lens and the plane glass plate, which is theta, and for normal incidence r is actually r, which is small, and this is equals to 0. So odd multiple of, so we can take 2n minus 1 into lambda by 2. Now 2 mu t cos, this is 1 actually for normal incidence, so 2 mu t equals to 2n minus 1. There is plus lambda by 2, which comes from actually Stokes treatment, lambda by 2. Now 2n plus 2n minus 1 and 1 lambda by 2 plus lambda by 2, which if we take minus, then we calculate easily. Minus lambda by 2, actually the path difference plus minus lambda by 2, so this is minus lambda by 2, and if this comes there, this is plus, so 2 mu t equals to 2n into lambda by 2, 2n into lambda by 2. Now 2 mu t, if t actually we have r square by 2r, so 2 mu t, so 2 mu into t equals to r square by 2r, so equals to 2n lambda by 2. Now 2 cancel out, and we have r square equals to actually r square equals to n lambda actually 2n lambda by mu, 2n lambda by mu by 2 and 2n lambda by mu, 2n lambda by 2 mu, and r square mu and r. So this is the r square, and we get dn by 2 whole square. Now dn actually the diameter of nth dark rings, so lambda r by 2 mu into 2n. Now dn square equals to 2, there is now 2n square equals to 4n 2n square dn square, actually 2 cancel out, and 1 actually 4n and lambda r by mu, and if dn equals to lambda r by mu and 2n root over of actually this. Now r actually constant, lambda equals to constant, mu constant, so dn varies as root over of 2n, which is actually even number, so rn square, so rn actually this is the radius of nth dark rings, so this is comes out, and dn the diameter of the dark rings, so lambda r by 2 mu, and 2n means this is actually even number, so 2n and dn square, so dn varies as root over of 2n. So they are the important questions. Prove that the diameter of dark rings is proportional to the square root of even numbers. So this is the important questions. This is important questions also which you get in your exam. So now first question, prove that the diameter of bright rings and which is proportional to the square root of odd number, and then prove that the diameter of dark rings is proportional to the square root of even number. So these two important questions you get in your exam, so prepare for these questions. Now thank you for watching this video. So thank you.